In this lecture, we are going to do introduction to valuation, the time value of money. One of the most important concepts in finance, in corporate finance, is the concept of valuation, specifically time value of money, because investments are made in anticipation of returns which comes in the future. So this lecture, we are going to look at the basics of the concept of valuation. The time value of money here, we are going to look at the concept of future value of an investment made today. Then we are going to look at present value of cash to be received at a future date. We are going to calculate return on investment, that is the rate, and we are going to predict how long it will take an investment to reach a desired value given a required rate of return. This is what we are going to look at in this lecture. As much as possible, we'll try to make the lecture very practicalized, in a practicalized form, showing different ways we can do this computation. First, by way of introduction, the phrase time value of money refers to the fact that a dollar in hand today is worth more than a dollar promised at some point in time. This is often the fact that when you have a dollar in hand today, you can make an investment with it or trade with it, and you get a value that is higher than that later in the future. So on a practical level, one reason for this is that you could earn an interest while you wait. So a dollar will grow more than a dollar later. So the trade-off between the money you have now and the money later depends on certain factors. One of those factors is the rate of return that you can earn by investing the money. So a thorough understanding of this concept is very, very important to understand some of the subsequent lecture we are going to do in corporate finance, because most of the concept we are going to learn later are built on this concept of valuation, that is time value of money. So the first thing we look at is future value and compounding. Future value refers to the amount of money an investment will grow to over some period at some given interest rate. In another way, it is the cash value of an investment at some point in the future. The future value depends on basically on three components, and the three components are the amount of money you are investing today, which is the present value, the period of the investment, which is called the compounding period, and the interest rate. In this lecture, we are going to, whenever we see PV, it stands for present value. The compounding period will be using maybe interchangeably T or N. Then the interest rate, you may see in some cases R, in some cases I. So in doing investment, the investment can be done if it is a single period. For instance, if you want to find the future value given a rate of return or the interest rate, suppose you invest $100 into an account that pays 10% interest per year. How much will you have in 1 year? So in 1 year, you see there is $100 which will be there in 1 year. Then there is 10% you are going to earn on it. So if you multiply the 100 times the 10%, you are going to earn 10. You are going to earn 10 naira. So if you add it to the 100 naira, at the end of 1 year, you have 110 naira. So the 100 naira will grow to 110 naira, giving 10% rate of interest in 1 year. So we say that 110 naira is the future value of the 100 naira invested for 1 year at 10%. So what we mean is that 100 naira today is worth 110 naira in 1 year time if the rate of interest is 10%. So in general, it means that if you have a value, to grow it to a future value, you can multiply it by a factor 1 plus r. The r is the rate of return. So if our r is 10%, so this will be 1.1. If we multiply by 100, definitely we'll have 1.10. So this is for a single period. If it is for by demonstration, you can see that the 100 naira today giving 10% interest. The interest will be this times this, which is 10 naira. The principal is 10. So once you add them today, in future it will be 110. So the investment will grow to 100 plus z, that is 1 plus r of the naira invested. So if we multiply, you see it will grow to 110 naira. Now for a period that is more than 1 year, so it means the 110 naira for that year, if it is 2 years, after 1 year you will invest the 110 naira for another year. 110 at 10% will give us 11 naira interest. So if you add it to 110, you get 121 naira. This 121 naira is the future of 100 naira in 2 years at 10%. Another way of looking at it is that 1 year from now, you are effectively investing 110 at 10%. This is a single period problem. So you end up with 1.1 naira for every dollar invested. That is 121 naira. This 121 has 4 parts. The first part is that 100 naira original principal. The second part is the 10 naira you earn on the 100 naira earlier. You earn the first year, and the third part is another 10 naira you earn for the second year, for a total of 120. The last part is 1 naira you earn, you end up with the fourth part of the interest. That is the 10 naira you earn 1 naira on it. So that is the you earn in the second year on the interest paid in the first year. So this is the 1 naira. So for 2 periods, using a number line or timeline, you see 100 naira will be compounded to the 110 in the first year. Then in the second year, this 110 will earn 11 naira interest. So if you add the 11 naira to the 110, in the second year we have 121 naira. So for 2 years, this will grow to 1 plus r raised to power 2. If we remember the factor that we stated earlier. So instead of doing this calculation, you can easily multiply it by 1 plus r raised to power 2. Now, generally, this process of leaving money and any accumulated interest in an investment for more than one period, thereby reinvesting the interest, called compounding. Compounding the interest means interest on interest. You see, the interest we earn, if we go back, this interest we earn before, the 10 naira also earn interest of 1 naira. So that is why we call it interest on interest. So we call the result compound interest. With simple interest, the interest is not reinvested. So interest is earned each period only on the original principal. Let me give an instance. If you simple interest, the first interest is 10 naira. So in the second period, it's the same 10 naira we are going to earn. So because we are not going to earn interest on the interest. So we have an exercise here to demonstrate that. Suppose you locate a 2-year investment that pays this. If you invest this, how much will you have at the end of 2 years? How much is simple interest? How much is compound interest? So generally, if you are doing this, if you follow, for a T period, 1 naira invested for T period at the rate of R per period. This is the formula we are going to use. The 1 naira is the present value. This will be represented by PV later. Then the R, you can see, is T now. When it was 2 years, we represent it with 2. When it was 1 year, it was 1 plus R only. So the future value formula is this. So the expression this is sometimes called the future value interest factor, or just future value factor of 1 naira invested at R% for T period. So the abbreviation is this. So this value of 1 plus R raised to power 3 are normally given in table. This is the example of the table. For a larger table, we have a bigger table of it in Excel, which we will show you later in Excel. So you can see for future value, this is the value in the table from 1% to 20%, from 1 year to 10 year for a present value. This is for a future value. We are coming to that later. So to illustrate this, uh, we try to use use uh, look for the uh, future value of $100 for 5 years at 10% interest. So we show in the table for this is the 100 naira, if it will earn $10 interest. So that is 100 times 10% is 10. If you add these two, you get this one. The same thing, you bring down this is the opening for this period. If you multiply by 10%, you get this plus this, you get this. So this is the accumulation for 5 years. The total interest will be 61 naira. That is, we add all this, then the money will accumulate to 161.05. So if we use the formula directly, you can see that 1 plus 10% raised to power 5 will give us 1.15. So 1.15, 1.1 raised to power 5 will give us this. This is supposed to be raised to power 5, not 1.5. So 1.1 raised to power 5, so will give us this value. So you multiply it by $100, you can see $161.05, which is the ending value here. So we try to show the relationship between the compound value and interest rate, future value and interest rate. Future value depends critically on the assumed interest rate, particularly for long-lived investment. The figure below shows this relationship by plotting the growth of $1 for different rate. You can see $1 for different rate. We have 0%, 5%, 10%, 15%, and 20%. So, and length in time, we have 1 to 20. So by plotting this on graph, you notice that the future value of $1 after 10 years is about $6.20. So future value of $1 after 10 at 20%. At 20%, 10 years, look at it here, $6.19. Then, but it is only $2.60 at 10%. If we trace this back to 10%, this is 10%. So you can see that if by doubling the rate to 20%, the money more than double. This $6.19 is far more than $2.60. So in this case, doubling interest rate more than double the future value. So the graph here illustrates this movement. You can see the movement as the rate, as the period go further and the rate increases, the length of the future value increases. So future value, in solving future value, there are different methods we can use to solve it. First is the formula that I showed earlier. We can use table. We can use table, which I showed on Excel before. We can use financial calculator. We can use this function. This is present value, future value, payment, rate, and compounding period. We can use Excel. We can use future value function in Excel. Rate is the rate of return. NPAR is the compounding period. Payment, we will talk about this later. Present value and type, we'll talk about it later also. So this is a typical financial calculator. This is the function I said we are going to use. Even on our system here, we I have a sample of the calculator which we are going to be using, which we are going to use. So this is the calculator. This is a financial calculator we are going to use. So you can see the function here: PV, PMTN, rate, and future value. So we'll use it to demonstrate this. So the key PV and FV are present value and future value. The key N refers to the number of compounding period. 1 over I stands for the interest rate. So then this is the future value table. This is the table here at different rates and 1 to 10 years. Then this is Excel. For Excel, this is the function. When you use the function, you can bring out and enter the value here. You can see we did an example: find the future value of 400,000 in 7 years at 12% compounded annually. You see the 400,000 here. Present value, we are assuming we are parting with the money. That is why it's negative 12%. You can put it in percent or in fraction. This is 7 years. You can see the value here, 884,272. Look at the value here. So we are going to demonstrate all this. Then we remind you briefly that interest rates in real life situation are not compounded annually. They are compounded more than once in a year. So it is important we adjust the number of years and the interest rate to reflect this. So later in the lecture, we are going to talk about effective annual rate and APR. So loans are quoted as APR, but in the real sense, the rate that you pay is the effective annual rate, which we'll have a lecture for it later. So for instance, if interest rate is semi-annual, it means you are paying the interest twice in a year. If it's monthly, it's 12 times. So we gave the compounding period here. It can be annually, semi-annually, quarterly. These are the compounding period. So this is yearly. So to adjust it, if it is annual, you use it the way it is. If it's semi-annual, you adjust the rate by dividing it by 2. You adjust the period by multiplying it by 2. Quarterly, you divide by 4, you multiply it by 4. So that is how we do it. So this is how we do the adjustment. You multiply the number of years by the number of period per year. So that is the period, the N. Then the rate, you divide the rate by period per year. So if it is monthly, you divide it by 12. You multiply by 12. If it is semi-annually, you divide it by 2, you multiply it by 2. That is how we adjust it. So example, we take an example and use the method we said earlier. So you have located an investment that pay 10% semi-annually. The rate sound good to you, so you invest 400,000 naira. How much will you have in 3 years? So our N is 3. 10% semi-annually. This semi-annually, we are going to adjust it. We divide it by 2. So the present value is 400,000 naira. The rate is 10% divided by 2, which gives us 5%. The T will be 3 times 2. So if you put it in our formula, 400,000 1 plus 0.05 raised to power 6. So if you raise it to power 6, you have this. By the time you multiply, you have 536,038 naira 26 kobo. So that is the answer. So if we use table, let's go back to our table. That means we'll look for 5% under 6 and see the value. 5% under 6, you see 5% under 6, 1.34010. When we go back, you put the value, you use the value and just multiply by 400,000. That is the table value. You get the same answer. If we use calculator, let me bring out our calculator. Let me bring out our calculator. If we use calculator, this is our calculator. This is our calculator. Want to clear? To clear this work. Now let's see again. We have let me bring out the calculator again. The value that we are supposed to put, 400,000, 5%, then 6. So let me bring out the calculator again. Show tax bar. So we have our present value is 500,000, 600,000, 400,000 rather. 4, 1, 2, 3, 4, 5. That is our PV. We click 5%, 5. We click 6. The compounding period is 6. We click this. So we want to calculate future value. You press this compute, CMP, then you click future value. So we have 604057. The question is not coming out properly. Let me check the calculator again. Let me check the calculator again. I want to clear work first. I think I'm having some challenge with this my calculator. I'm having some challenge with this my calculator. First, I'm supposed to clear anything that is saving on this calculator. So I cannot see where I'll clear the work. So that we don't waste time, I'll leave it. Later, when I resolve, we'll see how to use it in our previous lecture. So the argument for Excel is this. Let me open the Excel so that we can use it and see. So this is our screen. So tax bar. Now let's use our Excel and see. So what we do first is to click the function here. We are looking for future value. Just type FV, enter. That is the future value. You click. So our rate is 5%. That is 5%. You can write it as percent. Period is 6. Our present value is 400,000 minus 400, 1, 2, 3. So you can see clearly this is the answer, 536038. So if I click OK, we'll see the answer will be displayed here. The answer will be displayed here. Let me bold it. This is the answer. Clearly, this is the answer here. So That is how we use uh, we use Excel to do. We have certain exercises here which you try to do on your own whenever you have time. Then let's look at present value. With present value, earlier in the future value, we are asking what will my 20,000 investment grow to if it earn this percent every year for the next 6 years. The answer is what we call future value of 20,000 invested at 6.5% for 6 years. You can verify the answer and see this is going to be the answer. So there's another type of question that comes up even more often in financial management that is obviously related to future value. Suppose you need to have 100,000 naira in 10 years and you can earn 6.5% on your money. How much do you have to invest today to reach our goal? So that means there is a money in future. You want to know the equivalent today. So the answer is this. How do we know this? Let's see. So for single period, like we said earlier, you you will have to discount it backward. You understand? We discount it by if it's 10%, we discount using the 10% backward. So in other words, we know future value here is 1 naira, but what is the present value? The answer isn't too hard to figure out. Whatever we invest will be 1.1 times bigger in the end. So because we need 1 naira in the end. So to find the present value, if we multiply the present value by 1.1, we have 1 naira. So to know the present value is by making the present value the subject of the formula. So we divide the 1 naira by this. So that is how we arrive at this. So in this case, the present value is the answer to the following question. What amount invested today will grow to 1 naira in 1 year if the interest rate is 10%? So present value is just the opposite of future value. Instead of compounding in present value, we discount it back to the present. Suppose you need $800 to buy textbook next year. You can earn 7% on your money. How much do you have to put today? So all you need to do, you discount it backward. So present value for a multiple period. For instance, you need 1,000 in 2 years. If you can earn 7%, how much do you have to invest to make sure you have the 1,000 when you need it? So in other words, what is the present value of 1,000 in 2 years if the relevant rate is 7%? So based on our knowledge, you know that the amount invested must grow to 1,000 over 2 years. In other words, it must be 1,000 this times this. So the present value is when you multiply this, you divide the 1,000 by this factor. So when it's divided, that means we need to invest 873 naira 44 kobo today in order to reach the goal of 1,000 in 2 years time. So as we have with future value, to get that of present value, we need to use the inverse of that factor. So for present value, we will just multiply by 1 over 1 plus r raised to power t. So the quantity days go by several names. In some places, you hear them, they call discount factor. You understand? And it is not surprising because it's often used as a discount rate to discount the value backward. The quantity in bracket is also called present value interest factor, like we have future value interest factor. So this value can be found in a table. So if you look at our table that I opened earlier, you can see this is the present value table that we'll use to do our computation. So if the finally calculating the present value of a future cash flow to determine its worth today is commonly called discounted cash flow valuation. So that is why most of the things we are going to do when it involves time value, we want to know the value today before we make an investment. So that is why it's called discounted cash flow valuation. So We also try to show the relationship between the uh, present value of $1 at different interest rate like we did earlier. So from the demonstration, we can see as the length of time until payment grows, present value decline. We can see at 0%, this is it, at 5%, like that, as it grows. So if you look out far enough, they will always get to close to zero, but they can never be zero. That is why you see this graph can come close to this zero line, but it will never touch it. This relationship in mathematics, we call it asymptote. Asymptote. Also, for a given length in time, the higher the discount rate, as the discount rate goes higher, the lower is the present value. So we can see it clearly from our table. As the discount rate is 20%, you can see as we go to 20 years, you can see it keeps reducing and is getting close to zero. So for each of them, we can see it clearly. So put another way, present value and discount rate are inversely related. Increasing the discount rate decreases the present value and vice versa. So present value and discounting. Like future value, we can also solve present value using all those ways we said earlier. Using formula, look at the formula here. We can use table, we can use calculator, and we can use Excel. So as a way of example, suppose you want to have $140,000 in 25 years. If you can earn 10% return, how much do you have to invest today? So these are the value. If we put it in the formula, future value is 140, 1 plus r, 1.1 raised to power minus 25, because it's 10%, we have 0.00999296. If we multiply this, we have $12,921.44. If we use table, this value here, we just get it from table, that is 25 and 10%. So the value from the table, if you check the table, is 009230. You can see they are almost similar. If you multiply, you get the same answer. If we use calculator, you just put the value for n, for rate, and for future value, and you get the answer. If we use Excel, let me go to Excel. Our n is 25, 10%, 140,000. We'll go to our Excel. Let's see how the answer will come out. If we go to our Excel, we are talking about present value now. So it's PV. So this is the rate here is 10%. 10%. 10%, not just 10. Or you write 0.1. 25 years, and the future value is 140,000. 40, 1, 2, 3. So you can see 121, 12,921. This negative say is showing that it's capital outflow. So if I click OK, you see the answer clearly here. So negative shows that it's capital outflow. That is for Excel understand that present value is outflow, future value is inflow. So we go. Now we have, like I said earlier, we have components, and those components, we have the rate, we have the compounding period, and we have the present value. So if we have some of these factors, we have the future value, we have the present value, we have the rate, we can find the time. If we have the time, if we have the time, we have the future value, present value, we can find the rate. So we want to see, sometimes you want to know the rate you are paying. If it is for a single period, this is easy. So all you do, you input those values. So assuming for 1 year investment, you put $1,250 and you get $1,350. So this is the present value, this is the future value, and for 1 year. this is the formula that we stated earlier. So this is 1350, 1250, 1 plus r. If we divide this by this, we have 1.08. So if you bring the 1 this side and subtract, this will amount to 8%. This will amount for 8%. Now, but for a multi-period, you can use financial calculator, or you can use solve for r in the equation, or you use the table, or you use the Excel. You use the rate function in Excel. So let's see, take some question. Example, at what rate of return will an investment of $100 double itself in 8 years? So whenever we are talking of an investment doubling itself, there is another rule we can use, which is called rule of 72. We'll come back to that later. We'll use rule of 72 first, you understand, and get the value. The rule of 72 stated that the number of years an investment will take to double itself is 72 divided by the rate of return. 72 divided by the rate of return will give us the value. So if we divide 72 by r and have the number of years, in this question the number of years is 8. So if we divide 72 by 8, we'll get the rate of return. So if you look, using the rule of 72, the rate will be 72 divided by the number of years. That is, r is equals to 72 divided by 8, which is 9%. Using our formula, you can see future value is 200. Since we are doubling 100, present value is 100. The double is 200. So 1 plus r, our t is 8. So if we solve further, this divided by this, we have 2. So 1 plus r is raised to power is equals to 2. So if we take the 8th root of this, we'll get rid of this power. So that is the 8th root. The 8th root of this is 1.09. If we subtract the minus 1, we have 9%. You can see the two answers are the same. So if we can use Excel, to demonstrate this. So let's go to our Excel. We can use Excel to demonstrate this. So using the rule of 72, if we have Excel, the future value is 200, the present value is 100, that is double, the time is 8 years. So if we want to find the rate now, which is this, we'll just say equal 72 divided by the number of years, which is 8. Enter. You can see we have 9, which is the same thing as what we have there. So I think this should be in percent, that is 9%. So this is how we can use 9%. Alternatively, we can use Excel to solve this using our rate function. So if we come here, we use the rate function equals to rate, the NPAR, number of periods is 8, which is here, comma, our payment we don't have, the present value is this, the future value is this. So there is no need to put any type or guess. Enter. Equals to, if we use the rate function, let me go again, our number of periods is 8, comma, our payment, we don't have payment, comma, our present value is minus this. that is outflow. That is why it gave me error earlier. Then our future value is this. You press enter, you can see that is 9%. So you can see the value is 9%. So we can use Excel to find the rate function in Excel to find those value also. Now you can use table also to find the value by tracing. If we are using table to find the value, you can see when we solve up to here, we have 1 plus r raised to power 8 is equals to 2. So all you do is you go to your table under 8, year 8, you look for 2 or the number that approximate to 2. Let's go to our Excel, to our table, and see whether we can trace. So if we go to the table, this is the future value, I think present value rather. This is present value. So under 8, if we check, no, future value rather, 1 plus something. So 8, if we check, where do we see 8? Value of 2. 1 point something. I think 9 is not here. 5, 10%. That is why. So I don't think we can be able to estimate it from this table. So I will demonstrate it further in some of our subsequent lecture. Now, so I have exercises here which we will do. The next thing we want to find is the compounding period. Suppose we were interested in purchasing an asset that costs 50,000 and we currently have 25,000. You can see this is doubling itself again. If we can earn 12% on this, how long until we have, how long are we going to get to 50%? We say find the answer. Finding the answer involves solving the last variable in the present value equation. So we are going to solve for the t. So this can be done using this method, rule of 72, because this is doubling itself, using calculator, using table, and NPAR function. So let's see. Using formula, PV is equals to this. 25,000 is equals to 50,000, 1 point this raised to power minus t. So once we divide this by this, we divide this by this, we have 1 over 2. Since there is minus here and it's 1 over 2, we can invert. That is how we got uh, 1.12 raised to power t equals to 2. So if we use trial and error, this will amount to 6 years. Then using the rule of 72, so the number of years is 72 over r squared. We already know the rate, which is 12%. So 72 divided by 12, you can see is 6 years approximately. We can use table. From the table, we trace 1.1 to 12%. We trace it down. We look down until we see 2. The table until you find the number equal to 2 or approximately 2. Trace it to the year and pick it. In this case, this is the number we saw and it's under 6. Thus, the answer is 6 years. If we want to use calculator, you put the value and you solve for n. If we want to use Excel, let me go to Excel. We'll use the NPAR, this thing. The rate is 12%. The present value is 25,000. The future value is 50,000. So let's go and use the NPAR function. We'll go to our Excel, number 4. So this is number 4, 50,000, present value 25,000. This is this thing. So we want to find the n. This is equal to NPAR. The rate is 12%, comma. The payment, no payment, another comma. The present value is minus this, comma, and the future value is this. Enter. So we have 6.116. This is approximately 6 years. Also, we can see this is uh, the 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 way to solve it. So using that, this is the solution here from the dialog box. Then we have exercises, and some of these things you can easily do them on the internet. We expect students to visit those internet and try to get acquainted with this. So in real life situation, you can see that some of these things are actually these are the way we go about it. So if you go to this popular site moneyshim.com, you will be able to do present value and future value. So this is the end of this lecture, and this lecture is on present value and future value of a lump sum or an amount. We are not talking about uh, um, payment that are regular in nature. So in the next lecture, we are going to look at payment that are regular in nature. So thank you for listening. This is the end of the lecture.